If you recall, pi over 4, pi over 2, 3 pi over 4, pi. It says to go from negative 2 pi to 2 pi. I'm not going to go that far because I think you'll see the point here. We're in this 9.5 section, the one that says tangent x at the top. And if you recall, the tangent graph looks something like this. I mean, so there's several copies of this one section here. It's the same idea as before. I mean, if we look at the entire tangent graph, is it 1-to-1 right now? No. So currently, the inverse will not be a function, but we're going to restrict it like we did with the sine and cosine graphs. And I mean, the piece that makes the most sense, yeah, it's this one right here centered around the origin. So if we just focus on this one copy of tangent, this hits every y value that's possible. And so I'm going to actually graph that real quick down here. So the restricted tangent graph is actually like the tangent graph that you're supposed to have memorized anyway. So that's not anything new. Okay, so this is the tangent graph. There's more, but this is the restricted part of the tangent graph. And now to graph the inverse tangent, we switch all our important details. And probably the easiest thing to do is to start with these vertical asymptotes. Instead of having vertical asymptotes, now they become horizontal asymptotes. Very good, at pi over 2 and negative pi over 2. When you graph the point negative pi over 4, negative 1, that becomes negative 1, and then negative pi over 4. 0, 0, when you flip that around, still 0, 0. Pi over 4, comma 1 will become 1 pi over 4. And I think in this case it's pretty clear the curve of the graph needs to look something like that. Okay, so there's the restricted tangent, there's the inverse tangent. You need to memorize the sine, cosine, and tangent restricted graphs and the inverse graphs, okay, as well as their domain and ranges, because they're going to come in handy later on today, and then certainly when we review, it'll just make life a whole bunch easier. Okay. So to finish this section off, this means tell me an angle where the tangent is 1, but since the domain for the angles is specifically from negative pi over 2 to pi over 2, we're only looking in quadrants 4 and 1 and only going backwards, and forwards pi over 2. Those are the only options. That's as far as we can go. All right. So what angle has a tangent of 1? Pi over 4. This means the exact same thing, right? We talked about that yesterday.
So why is there two different notations?
Because this is like how you would type it in the calculator if you needed to. And people get confused with the different ways of saying it, so you need to know.
Oh, okay.
You know what I mean? So like this means solve for x, where
we
x...
we can't type that into the calculator, so
You can't type what in the calculator?
10x equals 1.
Right, you cannot type this in. And the point is, I mean, we know these because these are nice unit circle values, but seeing the connection that these mean one and the same thing helps you remember that on the calculator. As soon as you type in inverse anything, what's it going to give me? The angle. The angle it has this specific sign value. Does that make sense? Erica?
So, for the inverses and the regular ones, they're always going to be the same.
For this, yes, because we're using restricted tangent and the inverse tangent. So yes.
Okay.
Okay, so tangent of x equals 0. Well, that means that the y-coordinate has to be 0, right? Because we do 0 over x. So where is the y-coordinate 0?
0.
At 0. Let's see. Negative root 3 over 3. But it's negative, right? So we got to do negative pi over 6 so that we get to quadrant 4. And then what angle has a tangent of root 3? Pi over 3. And these would be the same. Okay? Are there any questions on the restricted and the inverses? Yep.
So why is it negative pi over 6?
Because the tangent value is negative. And in the fourth quadrant, the coordinates are positive, negative, so that's the only
Oh.
time that it would be a negative tangent. Does that make sense? Okay. All right. Turn the page. So,
Oh, fun.
Oh, jeez.
no, these are quick problems. Quick problems
I
here.
said fun.
Yeah, I know. In chapter 3, we learned a long time ago that when you do an inverse inside of an original function, as long as the domains work, that they cancel out and you just get x, right? Or whatever's in there is what you get. Okay? The point I want to emphasize here is that x has to be in the domain of the inner function in order for that to work. And I think the example that I like to use, or that we use in chapter 3, was something like this. If I have something like f of x equals square root x, and f inverse of x equals x squared, they're not exactly inverses, but the reason they're not, if you take this, this is one scenario where you would not be able to calculate this because you can't take the square root of negative 2, right? However, if you switch the order,
You did the same
I did the same thing. If you switch the order, can you plug this into there?
Yeah.
What do you get?
4.
And then can you plug that value into here? And then you get, ooh. That's why these aren't inverses, right? The nice problems are, for example, like f of x equals x cubed and f inverse of x. What would the inverse of that be? Cube root of x. These are great examples of inverse functions because the domain and range for all of them, or for both of them, is all real numbers. So there's never any scenarios where you can't do it or you don't get the same answer. Like this, for example, if you do f of f inverse of 5, guess what you're going to get? You're going to get 5. Because when you plug in cube root of 5 and then you cube it, I mean, it'll work and you'll get 5. So the point I'm trying to make here is, on this page, as long as 3 works, so if 3 works for the inverse, meaning you're actually able to plug it in, then yes, your answer is going to be 3. They'll cancel out, and everybody's happy because you don't have to do that much work. Same with this. As long as 10 works, so if 10 works for which function here? Which function is on the inside? Just f, right? So as long as 10 works for f, then they will cancel out and you'll get 10. Okay? So let's start with some sign problems. Go ahead and tell me the domain and range, Kevin, for inverse sine and restricted sine. All of it? Okay, so then here, yes.
The domain is -1, 1, and then it's -5
Good. Okay. So here's how we do this. Let's look at the first problem. In fact, this entire page, what do we want to happen if we have inverse original, or vice versa, inverse original? What do we hope happens? That it just cancels and you get your answer, right? That only works, just like up here, if the inner function, you can actually plug in 1/2 into it. Okay? So what kind of function is this on the inside? Inverse of sine. So now what is the domain for inverse sine? -1 to 1. So is 1/2 between these two values?
Yes.
So that means that we're done. We don't have to do any work. Okay?
The range is the x.
Erica.
I'm kind of confused. So, like, if there's a time where we have to do work, is that kind of what you showed us before? Like,
I'll get there.
Okay, so
I'll
it's
get
not
there.
like-
Because there are times when, if it doesn't work like this, it's either completely impossible or where you can fudge it a little bit and make it work.
Okay.
Yes?
How do you know 1/2 works?
Because 1/2 is part of the domain of the inverse sine. Because the inverse sine domain was from -1 to 1, and 1/2 is between those two numbers.
Is it always so?
You always check in the domain, yes, of the inner function. Does that make sense? Okay. Let's try B. Ricky. Is 1/4 part of the domain of inverse sine? So what's the answer? Good. Ashley. What the heck does that mean again?
The inverse.
Okay. Is -0.2 in the domain of the inverse? So what's the answer? Good. Let's go to D. Austin. Is 0 in the domain of the inverse sine? So what's the answer?
4.
What are you doing on your iPad, Austin? Diana, what's the answer? 0. Very good. I thought out of those 3 problems you picked up on the pattern of If it's in the domain, the answer is just the number that's in there. Okay. If we go to part E, now things are a little different. What function is on the inside? Sine. Okay. Whenever you're doing compositions, I want you to remember it's either going to be inverse or restricted. Okay? So if I see sine, what you should be thinking about is this domain. Okay?
That was the range.
Well, it's the range of the inverse, but it's the domain of the restricted. Yeah. So pi over 3, is that between negative pi over 2 and pi over 2, Said? So what's the answer? Good. What about Amel, pi over 8? Is that going to be good?
Yes.
Okay, so that's easy. What about Allison? This one. What function should you be thinking about when you see this? What does arc mean? Kyle, what does arc mean? Inverse. So we should be thinking about the inverse sign. And Kyle, is 2 in the domain of inverse sign? It is not. So that presents a problem. We have two choices. One, it's either impossible, so we're going to write undefined, or we're going to try to actually figure it out. Okay? This is impossible. We've talked about this, right? There's no such thing as an angle that has a sine of 2. Okay? So this one is undefined. Patrick, what about H?
That's not possible.
Well, slow down a second.
Well, I mean, it's not in the domain, but it's possible.
Okay. So inside we have the restricted sign. Pi is not between negative pi over 2 and pi over 2. You guys see what he's saying? But do we know how to find the sign of pi?
Yeah.
Yes. So instead of writing undefined, here's what I'd like for you to do. So these are the ones that take one extra step. Figure it out. What is the sign of pi? 0. And now these become problems like the ones from yesterday. This means, if I just look at this, tell me the angle, right, that has a sine of 0. That's specifically on the right side of, right, because we're from negative pi over 2 to pi over 2. So where from here to here is the y-coordinate or the sine value 0? Well, pi over 2, the y-coordinate is 1. Pi, I agree, but is that on the right side? So we want to go here. That's 0. Very good. I just want to emphasize, this is a coincidence. Right? The inverse sine of 0 is 0. It's not like inverse sine of 1/2 would be 1/2. It just happens to be that it's the same. Yes?
So with those, we like
No, never. Yeah. Okay, so these last couple are the one. Actually, just H and I are the ones that are going to be a little trickier. Okay. So if I do this one here, arc sine of 7 pi over 4. 7 pi over 4, is that in the domain? It's not, but can we figure it out? Can we work with that? What's the sine of 7 pi over 4? Negative root 2 over 2. So you guys see what I'm doing? I'm kind of doing like 2 steps here. Not in the domain, so I can't just cancel it all out and be done with it. So what I do is figure this part out if I can. It's negative root 2 over 2. And now this means to find an angle where the sine is negative root 2 over 2. But again, quadrant 4 or 1 only. And we can only rotate that way or that way. Negative pi over 4. Very good. So you guys kind of see the 3 outcomes? It either, what's one of them?
Domain.
If the domain works, then Same answer, right? It cancels out. That's one option. Second option is if the domain doesn't work, it's either undefined or you actually have to like figure it out one step at a time. Okay? What about this one here? Is pi over 4 between negative pi over 2 and pi over 2?
Yes.
So, done. Okay? Let's move on. Let's try to get faster. Faster. Now we're on to inverse cosine and restricted cosine. Do you guys remember what part of the cosine graph we looked at? 0 to pi. Good. The range is still negative 1 to 1. So naturally for the inverse, negative 1 to 1, 0 to pi. Okay? You need to watch the video from yesterday. That would take me 20 minutes to explain. Okay. So same idea as the previous page, but now we're working with slightly different domains here, okay? Let's start with this first one. Paulina. Does 1/2 work with the inverse? So what's the answer? Good. Flip, what about B? What do you think? Does 3/4 work in the domain of the inverse? So what's the answer? Good.
Wait, why don't we ever look at the range?
Because what we're doing, remember, when there's a parentheses inside of a function, what you're doing is plugging it into the function.
Oh, okay.
So that means we're looking at domain. Now, as it turns out, the output of that would be in the range, but then you're also figuring out the cosine of that. You know what I mean? So all that matters is what is on the innermost function. All right. Brenda, what about this one here? Is negative 0.6 good? So what's the answer? Good. Is 0 good? Alexis. So answer? 0. Jenny, what about pi over 4? Is that good for restricted cosine?
Yeah.
So answer? Good. Elizabeth, what about pi over 8? Is that good for restricted cosine? So answer is good. Now we're on to something else. Erica.
For like C, are we looking at the domain like
Inverse.
on the 1 or?
Inverse.
Oh, okay.
Arc means inverse, right?
Yeah. Okay.
Erica, do you want to do G for us? What are we looking at?
We're looking at the inverse.
So is negative 3 in the domain of the inverse?
No.
No. So is this possible or is it undefined? Can we find the arc cosine of negative 3? No, we cannot. So undefined.
So like with regular numbers, we can't find it, but like it's a
Well, it depends on the function, right? Like if we look at this one now, let's see. What's up? You got it? All right, awesome.
I got 1. Because cosine of 3 pi over 2 is 0, right?
Cosine of 3 pi over 2 is 0, yes. And you have to figure that out because 3 pi over 2 is not in this window, right? It's too big. So we can go ahead and do that, but now I'm not following why this is 1.
It's 1 and 4.
0 to pi. So we're going from here to here. Where is the cosine going to be 0? We're looking for an angle where the pi over 2. That's what you meant. 1 pi over 2, right? Okay. This one has a restricted cosine in the inside. I think we know that that's too big, right? But can we find cosine of 11 pi over 4? Let's see. Pi over 4, the cosine is root 2 over 2. Is it negative or positive?
Negative.
Wait.
It'll be in the second quadrant, wouldn't it?
Yeah.
Because it's a little bit less than 12 pi over 4, which is a little bit less than 3 pi. So it'll be a little bit short of going to 3 pi.
Wait, where did you get negative 2
What did I get? What?
over 2? Negative 2 over 2.
Root 2? That's just pi over 4's x coordinate, right? All right, so now to figure this out, all we're doing is going from 0 to pi. Where is the angle that's going to give me this cosine value? It's not pi over 4 because that's positive.
3 pi over
There we go. 3 pi over 4. It's not negative pi over 4 because that would be in the wrong quadrant, and also the cosine of that is positive. What about this one here? Undefined. Good. All right, the tangent ones are actually really easy because there's only 2 scenarios.
That works or undefined?
Here's the nice part. I'm just writing down the domain and ranges from before. This domain is awesome, right? Because that means that everything works. You guys see what I'm talking about? So anytime you see inverse tangent or arc tangent on the inside, guess what?
It works.
It's going to work just fine. So let's find those right away. Inverse tangent, great. Everything works, right? Inverse tangent, awesome. That's going to work. That's not, we'll deal with that in a minute. Inverse tangent, no problem, right? Because it's all real numbers for the domain. All right? For the other ones, we do it the way we did before. So, yeah, C is between negative pi over 2 and pi over 2. That's no big deal. Same with D. This is the one that's a little too big, but we can find it. The tangent of 3 pi over 2 is what? Undefined, right? So I'm just going to stop right there because we can't do it. We'll finish up with these last kind of questions tomorrow. Homework is day 9.
Are we going to be working on the negative 5?
Yeah.